Hello, everybody. So thank you for joining the Istio Networking community meeting. It's already 11:03, so I think we could probably get started. I see the rate of people joining has slowed down a bit, so I guess we're good. So could you please add your names in the agenda as attendees, and let's see what we have. So we have a few very interesting topics. So one of them is a discussion about zone-aware load balancing, and Liam and Christopher signed up for this. The second item in the agenda is a document I'd like to share and present to the community about decomposing pilot. And the third item in the agenda is, let me see, because I somehow, there's something else which I just lost here. Okay, there it is. So question about the status of multi-cluster. Okay, I hope we will be able to cover all three items. So I propose we split in about like 20 minutes, 10 minutes, or maybe less for the last item if it's not too complicated. Okay. Liam, do you want to start? Are you
Sure.
there? You are there, yeah.
So yeah, zone-aware, when me and Chris originally added this to the list, we had every intention of implementing zone-aware, but I've had some discussions with Shahram, and we don't believe it's possible to actually do zone-aware load balancing based on how we name clusters in Istio. And the reason for that is basically that we use services in Kube most of the time, or as naming conventions for clusters, and multiple an envoy can belong therefore to two clusters, because you can have multiple services pointing to the same pod in Kube. And envoy has this requirement of you need to tell it which cluster it's in. And in the case where we have two, we can't tell it which cluster it's in. So the current thinking is, unless we provide some hard convention on people who are running in Kube that says you can only have a one-to-one relationship between, or a one-to-many service to pod relationship, not a many-to-many, that we basically can't support it, which comes on to the locality weighted endpoint stuff. I've been having chats with Shahram and Andrew. I know you had some use cases for this in kind of how we'd go about configuring it. I think generally we'd probably extend, is it the destination rules load balancing setting? We'd have to extend it to support this, like I think we have hashing as an extra one now where you can configure, and we'd probably want to set the configuration in there. So that's currently the thought process. I feel like I'm speaking into the abyss, so I'll let someone else talk. I don't know if Shahram or Chris has any specific opinions on any of this stuff, or Andrew, if you can share any use cases that you've mentioned before.
I have a question. Sorry, I'm hearing my voice come back through your microphone.
Let me...
Okay, now you're muted. My question is, why does the Kubernetes service need to show up in the cluster? If we want to support multiple services for a pod and we want the pod's identity to be in the cluster, why must the service that it belongs to be in its identity? In fact, wouldn't we expect that the assignment of a service to a pod be something that's dynamic, that wouldn't require recreating or renaming the identity of the envoy?
So I don't know if Shahram, you want to take this, because I don't know why we named this clusters like that, because I wasn't here for that. I joined at a later point.
So it's not on the inbound path. This whole thing is actually on the outbound path. I mean, you need to know what subset a pod belongs to. So when you're routing from a sidecar to a particular service, you need to know that this cluster belongs to that particular service. And when you do that, that's when you can actually go and fetch these list of all endpoints for that service and do all the load balancing stuff. So when you're essentially routing based on the service, I mean your cluster names actually have the service names embedded inside them. The problem is that, I mean, to put in a different way, the zone-aware routing, I think it works very well in a static deployments, like what Lyft has, where they manage the entire thing with salt stack, and they know the availability zone where a particular envoy is in, and they also know the availability zones of the destination envoys. So they can effectively specify the origin and the source clusters availability zones. And this actually allows Envoy to look up the availability zone of both clusters and then decide that if the target is actually within the same zone or a different zone. But in our case, where we are even looking at things like routing from one cluster to the other, or routing from one service to anything else, especially within Kubernetes, this whole thing is being generated dynamically. So we do not know a priori, like at bootstrap time, what is the cluster a pod will belong to. And so when we don't know what is a cluster and or the a pod will belong to, there is no way by which that zone-aware routing, the way it's set up currently, would work. But that said, the solution is there's a much more sophisticated and more flexible solution that I think Javi and Co actually added in Envoy. This is pretty much same as zone-aware routing, but with more knobs and tweaks, and it's a much more hierarchical system. It's called locality aware routing. So effectively, you can have multiple failure domains like data center, within a particular a rack and a pod, within so on and so forth, and then you can just effectively route requests to other clusters and other endpoints within the same locality, and then escalate slowly to other enclosures. So that should give you more control over this entire thing, and it's more flexible that way. So yeah, just because the zone-aware routing is not, that does not mean it's the end of the world.
Are there other implications for the fact that a service identity on a pod is embedded in the cluster name that's assigned to that pod?
It's not actually, no. There is no. We are not embedding the service identity of a pod in the cluster name for the pod. This is on the outbound path. When a pod is making a call to a different service, it has to go into some cluster, and when it goes into that cluster, we need to know the list of all endpoints that belong to that cluster. And the only way by which we would know the list of all endpoints that belong to that cluster is by looking at the service name to which the call is bound to. See what I'm saying? This is not for the inbound path. This is actually for the outbound path. The existing zone-aware routing requires you to start Envoy with a local cluster name, which should be deterministic in the sense that it should be one of the clusters that Envoy will actually also get.
Right, but if that cluster that Envoy gets, if that cluster name depends on the services, the Kubernetes services which are mapped to pods.
It depends on services. Irrespective of anything, whether it's Cloud Foundry or Kubernetes, right? You need to know if it's going to review service or rating service. So you need to generate a cluster for each of these services. That's it. But what this thing needs is that if you're launching a pod from product page, you need to tell Envoy from the very beginning that, hey, you're launching a pod that belongs to the product page cluster. If you don't tell it, then it has no way of knowing for the zone-aware routing. It has no way of knowing if it's going to route to reviews cluster, and the endpoints that it wants to route to are in the same zone or not, a different zone.
I have witnessed a bug recently where the telemetry and metrics aren't working if more than one service points to the same pod. I think we need to fix this in general for that.
This is not related to the availability zone issue. That could be the bug is there, but I think Gabe's question was that what are the other implications of having embedding the service name of a pod in the cluster name of the pod. And my point is we don't actually do that at all.
Is Kubernetes able to support multiple zones within a single Kubernetes cluster? Or is there the assumption that different zones have different Kubernetes clusters?
I think it can.
It can. There are certainly implementations out there that attach labels to pods that indicate their kind of network zonality.
Yeah,
and I know Azure does that. I know GKE does it.
Yeah, in GKE, there is a label attached to the node,
Yes.
but nobody prevents people from adding multiple labels
Right.
to mean the same thing.
We're not currently taking advantage of that in Istio. We don't have any configuration that's mapping that out for people. Right. What we would do, the XDS has a mechanism to pass that information in. And then we need to make sure that that information is also associated with endpoints that are registered in Pilot. Right. So that way then we serve clusters with labels on those endpoints, and then the zone-aware routing would work. We just haven't made that work end-to-end yet. And we need some configuration artifacts for that.
Aren't you specifically there speaking about the locality weighted stuff, though, not the zone-aware stuff?
Well, either, right? Yeah, I mean, locality weighted is a more general form of the zonal stuff, right? I think you can express the totality of the zonal stuff with the locality stuff.
Yeah, I think one of the key distinctions there is with zone aware, the Envoy instance itself is making the decision about, am I in the same zone? Where should I actually prefer a local cluster versus a remote one? Whereas with locality weighted, it's a central load balancer which is providing these assignments, making that determination.
Yeah.
Yeah, so we probably need a combination of the two then, Harvey, right? Because you still want Envoy to be able to make local decisions, right? If all of the most local things fail.
Yeah, so that's something that we probably then need to think a bit about, because right now they're implemented in a mutually exclusive manner. So
okay,
if you could open up a ticket and sort of articulate what we actually need there, we can try and see what we can do.
But what Shram's saying is that the local cluster name that we need, the Envoy needs to know which cluster. The Envoy needs to know to work out which cluster is part of, and therefore which other endpoints are in that same zone. We can't deterministically provide it.
So we can certainly do the zonal thing quite easily, right? Just Envoy needs to say what zone it's in, and then Pilot serves back endpoints with zonal labels.
Well, with zone-aware routing, oh, so you mean, yeah, so we kind of currently do that, we just don't have the local cluster name bootstrapped, right? So we have functionality in Kube that's setting the node annotations as regions, but until we can get the local cluster name in there, which is the part that we're kind of stuck on and that we don't think we can do, it's the local cluster name.
Right, and there's going to be a debate about what we should use as the zonal labels, right? Because you may have clusters physically co-located, right? And you have other clusters that are not. So we don't mean Kube cluster, and we don't really mean Envoy cluster. We literally mean zone label.
Yes, yeah, but the thing I'm talking about is specifically the local Envoy cluster name, not the Kube cluster stuff. The service zone is already set in Envoy currently in Istio. We just don't do anything about it, because we haven't set local cluster name, where when I say local cluster name, I mean the specific Envoy configuration cluster manager parameter, the bootstrap, which is different to the service zone.
Okay, yeah, we clearly have some work to do here.
Okay, so so I don't know if we want to continue having a discussion, have a discussion offline about the local cluster name stuff, but that we can have that conversation offline. In terms of the locality stuff, So this is the other locality weighted endpoint stuff. Like I said earlier, I think we should probably, I don't know if we need a full design doc or have some kind of API proposal. But basically, we're going to need to extend the load balance. Well, I forget what the exact name of the configuration is. But in the
do we need?
It's helpful to have some sort of design doc. Like, it doesn't have to be complicated or super detailed, but just to introduce the concept, so more people can, look at that, understand what we're talking about. I think it's some of the concepts could be, fairly unknown for some of the people that could have like real use cases.
Okay, I'll put a design doc together discussing kind of both of them. And then we can have the discussion as part of that as how or if we can work out the local cluster name and work out how we're going to extend the API for locality.
Yeah, I think that would be useful.
Okay, I can do that.
Right. So anything more on this topic?
Harvey, are there any other load balancer types coming in Envoy that we should be aware of?
Just trying to think. So Matt's been making some recent changes to the least request load balancer to make it work better for waiting. So that's one of the big changes which has happened recently, and we're just about to actually merge a PR to improve the behavior there, switching from power of two choice algorithm to EDF scheduling. I'm not aware of any others which are currently in flight. There is certainly sort of an intention to make more scalable in terms of like number of worker threads and endpoints, some of the load balancers, but no one's sort of like working on it actively right now.
Okay.
I guess the other thing is that we would probably have a partial way of like doing SNI based routing with the original destination clusters by just forwarding based on the header. Like we could just embed the DNS resolve by local sidecar in a HTTP header and then make the egress gateway use the IP in the header as a destination when it routes. So that's actually being done as we speak, which would help some use cases for the SNI routing and or yeah.
Is there an issue we can track for that?
I don't think there's an issue. I mean, at a high level, yes, SNI routing works. I think this is more deeper. There's probably an issue for that actually. I can just
for the SNI based original destination stuff specifically. That'd be great. If not, it's okay. But if you happen to have it.
As a general rule, it's a good idea to track things with issue because it helps us see how many things we want to cover, what to put on the roadmap, and where people can help as well. And it's very little effort to open one.
One last thought. Based on the perceived complexity of the locality, do we think there's still a chance this would be able to make it an alpha stage for 1.0? Or should we push it to post 1.0?
I think we can just solve it very easily with adding stuff to the destination rule, where we can allow people to specify the localities for individual services and their priorities and so on, and that should just give us the required feature, right, Louis? I mean, it's just like matter of locality LB routing does not require any knowledge of the source Envoy's locality, so it's just a matter of assigning weights and localities to subset of endpoints within a destination rule.
Yes and no, right? I mean, well, that's the API. The pragmatic aspect of it is whatever is assigning needs to know some information about locality to be able to make reasonable.
No. So the way it's structured, the locality LB routing is that it just simply starts on the lowest. It's weighted routing. So if it picks the one which has the highest weight, and so
right. No, I know, but something has to assign the weight, right?
Oh, that's
why I say it's just the that's just the API. The API part is not that complicated. The intelligence is in the thing that assigns the weight.
Yeah.
So while So it's unlikely that we will have, we're certainly not going to block 1.0 and having it work in the implementation of it. We haven't figured out what the intelligence needs to be or what information we need to make that decision, though we could probably write a design doc for it. So it seems risky to, like, I certainly wouldn't make any commitments about it being in 1.0. That seems like a real stretch. It might end up in 1.0 as an alpha feature. But those are two different things, right?
Yeah, that's true. Yeah.
Okay, time to move to the second item on the agenda, which is decomposing pilots. So let me just share my screen here. Right, so there is this design doc I shared with you, and I'm gonna start actually not to the introduction that goes straight to the meat. I'm gonna start with making sure everybody is aware of the current design of pilot. And the current architecture with plugins, basically. So Pilot right now has multiple plugins for the different platforms. It has a plugin for Kubernetes services and endpoints. It also reads CRDs from Kubernetes. There is a separate plugin to discover services and endpoints for Eureka or Consul Service Registry. In addition, we use a file-based plugin for testing. We have, there is the Copilot, which runs out of process, but based on the latest information, it also has a little plugin in Pilot. So we have a bunch of like platform-dependent plugins. They all feed information of various types into Pilot, whether that's config or services or endpoints, they feed into Pilot, right? And I depicted here Pilot as a 3-layer cake. The first layer, which I named config ingestion layer in Pilot, right? That's the part where we ingest stuff. Then we have the core data layer, which is, or core data model layer, which is basically our data store. We have there a cache. Kube client maintains a cache of services, endpoints, CRDs. We also do some like copying into the Istio config store. So we have a bunch of like data structures there. The good part is that all these data stores have Golang interfaces for CRUD operations. Like on one side, we see add, update, delete notification handlers. On the other side, we see the get list interface. And this one in particular, the get list or the data access, is used intensively by the third layer of Pilot, which is the proxy serving layer. So the proxy serving layer basically reads data that we have in Pilot and produces a Envoy configuration that then sends over the ADS protocol, which is a gRPC bidirectional streaming protocol, to Envoy. Okay. So what are some of the issues with the current model? So for instance, we have a tight dependency on Kubernetes, and more specifically on the Kube API server. That's one thing. It's kind of hard to add a new service registry to Pilot without recompiling Pilot. It basically forces people to learn the build process of Pilot. In addition, it's actually pretty hard to test Pilot. Like, there is a SWAT test team that tried to develop a simpler framework for Pilot, and they discovered it's not so obvious and not so simple to do because of all this tight coupling with the various platforms. And of course, like there is not a clear contract between Pilot and Kubernetes or the other platforms, or it's right now it's underspecified. Basically, there is everybody adds stuff to Pilot as they seem fit, so that ends up in Pilot becoming like slowly like a bloated control plane. And we would like to move away from that. So we would like to make Pilot a bit more, like really decompose it. So make it more like more lean, less platform dependent, and basically easier to extend. So make it easier for other people, and proprietary service registries, proprietary config servers to be able to feed data into Pilot. And like this document I shared actually a bit late this morning, it's proposing a more of a mechanism for doing so. It's proposing an API that we can use, and it's actually the existing API and protocol. And it's really the mechanism by which we can achieve this decomposition. And I can show another picture and talk a bit about this. I want to just emphasize that it's all meant to be a gradual move. It's not proposing a redesign of Pilot. It's something we would like to do incrementally to help with the end goal, which is a more like stable, scalable, and performant Pilot, also more extendable. And obviously, it's again open to feedback from the community, and it's that's pretty much it. So the idea of decomposition is to gradually, and I emphasize gradually, migrate the various plugins as out-of-process adapters to Pilot, or also out-of-process servers, for instance, Gale, which can aggregate other plugins, for instance, a Kubernetes plugin. And we can achieve this by introducing a very concrete layer, an API layer around Pilot. And we already have existing Istio APIs for service entry, gateways, virtual service. All these are absolutely sufficient right now to configure Pilot. And we would like to use those as the mesh configuration API, as the API layer around Pilot. And we can carry those APIs over a transport protocol that needs to be that best would be to use a gRPC bidirectional streaming protocol. And for instance, the ADS protocol that Envoy uses, it's a very good choice for this. It's very generic. It can actually carry other things than listeners and clusters. It can carry pretty much anything. And it's already defined, so we could reuse it. And in here in this diagram that I'm sharing, I gave a name. I called it mesh config protocol, but in fact, it's really ADS protocol under the hood. We can obviously name those things as we decide in the community. The more important thing is to agree on the mechanism and the fact that we do need an API layer around Pilot. And so in here, there is maybe one more thing I have not talked about yet, and it's that, and in fact, the changes in Pilot to achieve this are fairly simple, that we don't need to change all the 3 layers of Pilot. So everything that is discussed in this document regards the config ingestion layer, which is the first layer. And we can also slightly change the core data model layer in the sense that we can have a common core model as opposed to the 2 dichotomies like services and endpoints and configs with 2 separate interfaces. So that can be easily achieved just via Golang interface wrapper. So it's not really a change in the internal Pilot code so much. And obviously the proxy serving layer is not is out of scope for now. There are many optimizations that are possible in the future, but there'll be separate, documents and design efforts for that. Okay. Right. So Do you want to add anything, Louis?
Hopefully this isn't particularly controversial. I think the other thing that's going on, we have a lot of common code in Istio for dealing with the vagaries of integrating with Kubernetes, right? Managing CRDs, versioning CRDs, checking that resources that are pushed into Kubernetes have valid schema, and that code has kind of ended up being smeared across a variety of components, and we'd like to put that in one place so that the other components don't have to deal with it, don't have to take that as a production risk, and so we get some developer efficiencies around having one mechanism for dealing with the kind of user-facing configuration side. So there's an effort being proposed, which we've pretty much forever called Galley, which is to have this other component that sits between the Kube API server and any of the control plane components that kind of carries those concerns. So these two proposals kind of go hand in hand. So there's in parallel to this change, there's a similar change happening in Mixer, right? Where Mixer itself also has an API for receiving configuration, and Mixer's adapters are moving to out of process, and Mixer itself is becoming simpler. So this kind of parallels that architectural change.
I just want to say I love it, and it's going to make the Cloud Foundry integration way easier. So thank you. I'm looking forward to seeing how it shapes up, and if there's ways that we can contribute or start using the early interfaces, I think we'd be excited to do that.
Awesome.
Awesome. Thanks. Yeah.
We had a hard time coming up with a reason not to do it.
Can I ask a question? Where the remote pilots are talking to the central pilot, what type of stuff are they talking about? Is it a one-way conversation? Is it kind of a two-way stream? And what kind of information are they actually going to be sharing between each other?
Yeah, that's a very good question. So in fact, we thought a bit about this. So right now, for instance, it's going to be bi-directional, right? Like the reasons for choosing ADS as a protocol, it's going to be bi-directional, and there is the ability to send ACK and NACks back to the config server right now. I think ADS has that. And we can I think we can further refine the details about, what will happen.
So I think, right, that there are only so many topologies that make sense, right? So you could imagine a world where, you've got all your configuration sources and they're feeding into Pilot, but then you want to create another remote Pilot that's basically a replica of it, right? And you don't want to do the N integrations into N pilots. So it might be easier to just do the integration into one Pilot and then have it basically act as an intermediate replication mechanism. I don't think we would do bidirectional between two pilots.
No, I was thinking maybe not between the two pilots, but I was thinking bidirectional more in the sense that ACK/NACK, I received your thing.
Right, but that's between the kind of providers of configuration and pilot, right? But he was asking about the remote pilot.
I'm sorry, I completely missed the point. Okay, yes. So yeah, the remote pilot is exactly as Louis said, and so this is for instance, what I haven't mentioned is that we plan to support multiple streams of config in the same time. So for instance, some configuration can come from console as a service registry, right? While that would be services and endpoints, and in the same time get CRDs from Galley, let's say, or use some completely other concurrent adapter, right? And Pilot will be able to merge those as long as they have separate networking domains and organizational domains. So in the case of remote Pilot, for instance, it's very foreseeable that remote Pilot would send something like service entries containing a service with a list of endpoints from a cluster, while some other configuration would come from Galley or some config server.
That is how it works today with the in-process service registries, right?
Right. Yeah. So it works that way with service registry. We haven't really formalized how we would do domain merging for non-service registry stuff. So that's going to take some work, right? Really, right now you have kind of one master source of, say, virtual service or gateway, or you have you have a guarantee that the two sources of that information are entirely disjoint and there's no merge semantics, right?
Yes, I see what you're saying.
So the API would just need to specify the constraints on those types of things. But given that the most likely first rounds will be either we already have merging for service entry, and we have disjoint sets for configuration sources, it isn't really a problem. But when we have, like, as this scales out, you could imagine where they start to overlap a bit, and you'll have to have precedents or other things.
Yeah. There are clearly many like details to be fleshed out, right? There will be a clear evolution of the API as well to be able to support all the like multi-cluster scenarios and also an increased case. So, and my point here is not to get into the API part, because I know there are like many people who can do that very well, and I think there'll be a lot of discussion, in PRs and other design docs. But I just want to like basically introduce the concept and get input on that.
Yeah, so I think in terms of the incremental execution plan, right, we already have resources that we can start to build an API around. Jason's been looking at doing that. We know how to do the internal refactoring of Pilot to kind of make both the old and the new ingestion pipeline coexist. We'd like to get Galley into 1.0 because we'd like any of the API validation work to be done by Galley, like the user-facing API validation, because there's a clear distinction here between kind of, Istio's user-facing APIs and system integration concerns, like Cloud Foundry, where they have their own API, or Console, right, where there are pre-existing systems. And yeah, so there are kind of two sets of problems. It's clearly hit or miss whether that would happen in 1.0 or not, but I think we'd like to make it happen. So we'd like to get at least the basic version of this API working with the existing resources that we have, do the minimally invasive change in Pilot, but have a fallback plan where that doesn't work.
Yeah.
Because obviously 1.0 is on a fairly tight schedule, or at least we'd like it to be. And then post 1.0, we could talk about making like what structural improvements we'd make to this API, right, to make it more consumable, right, more performant, cover more of the use cases.
Right. So for 1.0, Jason and I will work on just some, reference implementation for this MCP/ADS server and client, and then how it feeds into, into the notification handlers and all that. And we can have a config flag to say, enable this mode of ingestion or not. And it's meant to be really like gradual and non-invasive. I want to emphasize this because I'm among the people who are really against making changes before 1.0 because we don't want to stabilize. But on the other hand, would sort of like to make some progress with, future extensibility.
And if we do a good job, Gabe, then I think, it might make your life obviously easier. So that would be a nice side effect.
Yeah, let us know if we can contribute. This is pretty close to what we were imagining doing with Copilot anyway. We just in the last couple of weeks, we've talked about changing the RPC between our platform adapter and Copilot to simply be the V3 alpha protos themselves. So yeah.
Okay.
Yeah.
So go ahead, Lynn.
Yeah, I was just going to say, I think this is an interesting way. I'm curious on your thoughts on how this impact the existing multi-cluster support in Istio, which we kind of run Istio remote chat on the secondary cluster and point back to the primary cluster's Pilot endpoint. With this model, I think it would be a lot easier to run Istio, the secondary Pilot, instead of pointing back to the endpoint on the first Pilot on the secondary cluster. So we actually could potentially having pilot running on both clusters?
Right. So
Yeah.
I mean, there's a couple of deployment options, right? We could have Galley, right, running in both clusters, sending just endpoint information to the other cluster while sending all the other configuration to the local pilot, right? That way we get endpoint replication and service replication, right? Right. So it would be just a slightly different way of implementing the same pattern we have today. Right, because this API would support more than one Galley calling into pilot at the same time.
Right, but it will also support the remote pilot, right? And for cases like zero VPN, for instance, the remote pilot can aggregate the endpoints and
right,
send,
it's just
send
a bigger.
it to
I think that's a
pilot
bigger
also.
change in the short term.
Yeah, that's not for the short term, right? But yeah.
Yes. Yeah, I don't think that would be 1.0.
Okay,
I
so
think
for
we'd
our
still
we still do is still remote the chat point to the pilot endpoint on the
more or less.
Yeah.
Though you
Okay.
could obviously tell Galley what things you wanted to receive from it.
So you were just saying this particular Galley in the diagram, it can actually be the configuration server and the validation server for multiple Kubernetes clusters.
Well,
and
you
multiple
can,
pilots?
each Kubernetes cluster could have a Galley, right? That's acting as the local validator,
Right.
But if all those clusters were basically clones of each other from a configuration standpoint, then really they're just acting as replication. And the only thing that's unique to each cluster is the set of endpoints and services that are running there, but the configuration is identical, right? So the only thing that needs to happen is the federation of endpoints, right? Which is really what the current solution does.
Right. Yeah. And in this way, the other way it's nice is if I don't need, let's say if I don't need console, I don't need Cloud Foundry, or I don't need a Eureka, I don't have to install their MCP server, right? I can only install what I need.
Absolutely, yeah. So in here, you the bottom part is like it's pick and choose, right?
Yeah.
You don't have to install all the bottom part. So in fact, this reduces, like, if you want the binary size of pilot also, and it allows you to customize really your deployment. And I guess one of the good things is that it also decouples the release cycle, right? So people can write their own Galley and plug it into pilot. As long as the API versioning and backward compatibility is maintained, we can evolve independently.
Right, and it doesn't have to run on the same pod as pilot either, right?
Oh, obviously, yes. Actually, that's a very good thing you brought up, because Sriram said that sometimes there may be, very strict latency concerns, right? So in that case, we can always run the out-of-process adapter on the same host as pilot, right? But it's not a requirement. So it can run anywhere because it will talk over the gRPC protocol with pilot.
Mm-hmm.
All right, it sounds like there's resounding either assent or consensus that we should go ahead and do this. Are there any execution or timeline concerns? Other than
So
the ones I mentioned?
About getting it into 1.0?
Yes.
About getting it into
Yes,
1.0?
you
I mean,
missed that.
I would very much like to see it in 1.0 as well. And I think we can probably help out on the engineering side.
Okay.
Great, thank you. Okay, so yeah.
Is 1.0 still targeting July? Because this
That
seems
is
like
the
a
hope,
lot of
yes.
work in
Yes.
timeframe.
Right, so that's why we're taking a very incremental approach to this, and it will probably be, unless things go perfectly, it will probably be a flag-enabled feature. So Galley is already going to be present in 1.0 because it's already the webhook validator for the API calls.
Mm-hmm.
So it's kind of already there, right? It's just its role is increasing.
Okay.
The changes in pilot don't look horrendous.
No, they are actually very small. Yeah, that's the good part.
So there's a pretty good chance. But yeah, clearly there will be bumps in the road in getting.
We thought about the impact here on like a la carte deployments, because we need to think through some of the logistics there. Like in particular, one of the common use cases that we're seeing is people that want to do pilot-only deployments, and that gets a little bit heavier weight to run potentially. In other ways, this actually makes it substantially easier.
Right. Yeah. In the long run, it should make it easier.
Yeah. In the short, I just want to make sure that we don't kind of bungle that in the 1.0 timeframe and make things more coupled than. We should be careful.
Right. So we already have done the decoupling and the install for Mixer. Right. The only other component, other than you're going to have Galley, but it's there anyway, and you want it because it's your API validation, and your API is not going to be usable if it's not validated. So the only other one that I'm aware of right now is the coupling to Citadel in the Webhook stuff.
Yep.
Which, if you wanted to work on something to make decoupling better, that would be the one to look at, I think. I'm not aware of anything else obvious.
I thought we still had Citadel dependencies for MTLS to the control plane, even outside of other stuff.
It's entirely likely that you're right. I don't know them off the top of my head, but if we can identify that we are and put them on a list, then we can certainly talk about it.
Alrighty.
I think Tyler probably needs to know if Citadel is there or not.
Yes, definitely.
The other piece of work that probably isn't going to happen in 1.0 are some of the other things that we wanted to do with Node Agent, right? Around using Pilot to be the driver of configuration for Node Agent, right? Like the latency around startup and getting the first config, or looking at doing that in injection time, like all those types of things. I think there's limited runway to take on that type of work. But it's something that will come out post 1.0. Like, because clearly we'll do this API, and then there'll be another version of this API, right? When we figure out what we really want to do with this API. So yeah, usual kind of stuff. And yeah, so I don't know if there's some coupling also Node Agent to Citadel. That's the other place there would be some, right?
Yeah, I'm not sure. And
have we done SDS yet?
Yeah,
It's not happening on Pilot, right?
Yeah, it's not on Pilot. But
I mean, Citadel should do that, but is it even implemented in Envoy?
It's not in Envoy yet.
Okay, that's fine.
Yeah, okay, well then no. Right, so that would be something nice to also fix for 1.0, but like it seems risky to assume that would be there.
I think we just need to complete the filter chain match in Envoy so that we can actually fix the long-standing issues in certain aspects of Pilot. And with that, we should have enough infrastructure in place to even get some of the most commonly asked things like sticky sessions and the zone-aware routing and all of the stuff. We should be able to tackle with what we have in Envoy today.
Yeah. I mean, even with our current feature set, right, and solving for some of the known bugs, right, we already have a totally valid 1.0 product.
Yeah. I guess there are few key roadblocks here and there, something like people who still have WebSocket stuff when they want to use that. We need to make sure that the filter chains are actually active for WebSockets, which is a discussion that's happening in Envoy, and then some of these small things that just need to be resolved.
Yeah.
Okay.
All right. So we're all going to go ahead and cross our fingers that we get all of this done by 1.0.
Yeah. I mean, it may not be all of this, there'll be a good starting point, I think. Yeah.
Right, because one thing we might do, we might move the in-process adapters for things like Console and Zookeeper. We can move them behind the API surface without moving them out of the process.
Yeah.
Right. So we can do things like that.
Exactly. So.
Yeah, because as long as we get the API surface down, I think that's the key thing for 1.0. Everything else.
Yeah, exactly. That is the meat of this proposal.
What is the status of the prototype work you and Jason have been looking at?
So Jason is very fast.
Okay.
So he's got lots of stuff already. So I guess we'll share again, like maybe in 2 weeks.
Well, if there are any ongoing PRs, can we put them under the subject?
Yeah,
here
yeah,
so people can
I'll
just have the
add,
context?
exactly. I'll definitely do that. He has a branch created, and yeah, he had initially a PR, but then we like changed based on, using the ADS protocol because okay. All right, good. We have 7 more minutes. So actually, for this, please read into more detail and provide comments. And we'll move to the next item, which is a question from Gabe. What is the status of multi-cluster for case when clusters are when clusters are on different L3 networks?
Just curious. Sriram sent me something just now, but I'm curious what's going on there.
Oh, that was just the thing. I mean, I think what he's asking more are you looking at Cloud Foundry plus K8s as one single mesh?
Yeah, so we're thinking about Cloud Foundry, K8s, eventually maybe Windows, and we're thinking about we're trying to figure out whether there's one Istio or multiple Istios, and we're imagining that there's going to be a gateway for ingress to each cluster. So there'll be a flat network within the cluster, but then crossing between clusters. We're trying to imagine how that would work.
Right. So I think. Yeah, I think there's 2 orthogonal things there, Gabe, right? One is how many control planes you need, and then how many L3 networks you have.
Right.
And those shouldn't matter. Like those should be separate things.
Yeah, I'm aware, and I'm trying to say that I think we're agnostic about the former, but we're pretty certain that we're going to have several different L3 networks.
Yeah, so the stuff that Sriram shared with you, which is kind of showing an example of how to set up gateways to achieve the effect of routing across multiple L3 networks, right? You can kind of ball and twine that together today with the existing APIs.
Yeah, I'm actually working on a blog post that'll be out in the next little bit that kind of goes over how you can use gateways to do that.
Yeah. Have you seen Sriram's demo thingy?
Yeah, he just sent me the link. Sriram, is it okay if we post it in the notes here?
Yeah, sure, yeah.
And I have a similar one that's might have a hybrid demo I'll post as well.
Yeah,
and that's so that's slightly variant.
Yeah, so that's the kind of the short term is like we'll tell people how to ball and twine it. Like obviously we want to provide a much better, more usable, more scalable experience around this going forward. I doubt that would get into 1.0 because it requires Istio to understand network topologies. Right, we need to be able to label endpoints as being part of networks.
Yeah, that's what I was going to get at. And I was actually going to ask how this fits in with what you were just talking about with decomposing pilot, because it seems like there's that labeling needs to stay as it flows between these pilots that are passing data, right?
Yeah. So they basically we need to label networks. We haven't figured out exactly how we're going to do that yet. That will be part of the API clearly. So having specified what the API contract is, then we can talk about how to evolve it to cover that type of concept. It's being a large cloud vendor. It's something that Google has been doing internally for a while. So we have some design ideas, but we haven't really figured. We need the API changes to be able to make this happen.
Yeah, well, we need to hash some of that out too, because it's not necessarily required that you propagate all endpoint data, especially when you don't have pod-to-pod connectivity.
Yeah, there's all kinds of things. Like when we talked about the zone-aware load balancing stuff, right? How does that play in with that? Right, there's a lot of cross-cutting concerns.
And remark, a service entry does not force you to propagate all endpoints for that service, right? You can just propagate the gateway endpoint.
Exactly.
Right.
Which is probably the approach we should take. But then you have other concerns like how you represent aggregated load of the endpoints in the gateway. Right. Anyway.
Right. So if you look at that document I wrote last year, it's still valid. Mm-hmm. I have to update it to use service entries, but.
Andrea, would you post that link here in the notes also, please?
Oh yeah, sure. Yeah, it's an older doc. Yeah.
The only other thing, coming back to the API discussion, decomposing pilot, please provide name suggestions. We picked mesh configuration API.
MCA.
We should just call it SQL.
Why?
Well, the joke was why MCA. But we're clearly not married to any particular name. I mean, the goal of that API, right, is to be able to declare the configuration.
You should call it a squadron, group of pilots.
Yeah. Right, that's orthogonal, right? The goal of the API is to declare all the properties of your network, right?
Yeah.
Do we envision that API being materially different from the like V3 Alpha networking components that are inside of Pilot right now?
No.
Certainly not for 1.0.
Yeah, I would hope initially it's just like CRUD for the networking APIs.
Okay, cool.
Exactly. In fact, I want to add it's not just the networking because Pilot also needs authentication. So there is a CRD to add authentication. So that will be part of this like API substrate as well. And we definitely don't want to have another API. We want to use those APIs.
Right.
They are already there.
Yeah, they'll just evolve over time.
Yeah.
Right? So they may go through like, there'll be another version maybe at some point later this year as we figure out that it doesn't cover all the things we wanted to cover. And the reason why Andrew mentioned the authentication policy stuff is because the authentication policy declares which services are allowed to talk to which other services. So it's used for graph pruning.
Yeah.
And it goes into like Envoy config, right? It's a filter.
But it also informs like, configuring Envoy.
Yeah.
Oh yeah, that auth policy actually is only for configuring Envoy.
Right, so that one
the
is
other
not
one
a
is
mixer policy. I think it's that's why it's actually it's with Pilot's API, but it's not a networking API. It's an auth security API.
Okay.
And did I hear that Citadel is required to do MTLS within Mesh, or can you just do that with certs inside of Pilot somehow?
So in theory, you could, but we certainly haven't made that easy.
Okay.
Right. So that's one of those abstractions, right, that the API probably doesn't cover well enough today to make swapping that simple. Right. You can obviously live at the same level as the Citadel API, so you can look like a Citadel.
Okay. Yeah, that could work for us.
Right. And there are the gateway configuration stuff is probably sufficient for gateways to be able to use a different CA management technique. But for sidecars, we don't really have a resource that meets the same requirement entirely.
Yeah, destination rule covers some of this because it does allow you to specify CA cert bundles that you use, but it's not the full. It's not like a drop-in replacement to be able to get rid of CA from TLS.
Yeah, so yeah, probably some improvements to destination rule and auth policy would be needed. But it's probably pretty close-ish.
Yeah, I think it's very close. Do we have a story for unifying those two, by the way? That had been kind of on the back burner. Or
into one resource?
Well, I don't think it's necessary to do that, but right now they both talk about which certs are required to talk to a service and all that stuff. There's a little bit of duplication.
They changed it, right? The destination policies, the rules is the only way to configure the listeners.
Oh, we did. Okay, beautiful. I missed that.
On the outbound path, actually, but not on the inbound path. They still have a separate resource.
Oh, okay.
Yeah.
That's not the worst, I guess.
Yeah, and that's probably necessary to have that split, right, for more complex use cases.
Yeah.
Right. So yes, it's kind of a usability tax on some people, but it's also a necessary evil for others.
Yeah. So I think we're 1 minute over the time. So thank you very much for attending and providing feedback. And I'll see you in 2 weeks. Okay.
All right.
Thanks. Bye.
Thanks, everyone.
Have a nice day.